Hi ladies, in this video we're going to go through 5J, solving simultaneous equations using matrices. The very last topic in matrices, let me just double check. Yes, and then you've got some application style questions. Now simultaneous equations you might have found difficult when you did algebra back in year 10 or linear equations back in year 10. With matrices, they're not as scary. They're actually, if you understand matrices and how these the coefficients and the constants, everything is represented, then you're good to go with your matrices. So you can see here we've got an example, our two equations. So remember, simultaneous equations just means more than one equation. Okay, so in general, we're only dealing with two, so good. Actually, you might get more than two, but the same concept applies. Okay, so it doesn't matter if you've got three equations, it's the same thing. Okay, with our matrix, or with our equation, so let's look at the first one, 2x plus 3y equals 12. In our first matrix, the first column represents the x coefficient, and the second column represents the y coefficient, because when you remember, when we multiply matrices, we go across and down. We run, then we dive. So it's going to be 2 times x, 3 times y. Okay, so you can see 2x plus 3 times y. Okay, so run, dive. And then we do the same for the second row. We run and then we dive. So it's 4 times x minus 3 times y. Okay. Now, it's equal to whatever the constant is, so 12 and x. Now, the order of your coefficients does matter. So if your equations aren't in this form, okay, so you can see x, y is here. Sometimes you do get tricky ones where they might put it in a different order. They might put in further maths, they do put in a z. So you might have an x, y, z, so 3 equations. They might have an equation where there is no, say, x component or x term. So in your matrix, you would have to have a 0. Okay, so it'd be 0 times x, so it's 0. Just trying to think what else to tell you. So you can kind of read straight away with matrices. The tricky thing with testing simultaneous equations using matrices is, even if you don't understand how to solve them using matrices, you can solve them using linear equations. So remember, using the solve function on your calculator. So you've got 2 equations there. You just solve first equation and second equation, comma x, spits out your answer. But let's focus on matrices for now, because I think I'm getting carried away with just linear equations. All right, so here's our matrix equation. Now, to solve that, remember, when we're taking the inverse, it kind of undoes things. So as you can see, this part here, AX equals B, if we want to get this unknown matrix, this X matrix, when we did algebra, we would say, oh, let's divide both sides by A and leaves X by itself. In matrices, we don't do division, okay? So matrices, division of matrices does not exist, but we take the inverse, okay? So instead of dividing by A, we take the inverse of A. And remember, the inverse of A multiplied by A gives us 1. But whatever we do to the left-hand side, you have to do to the right-hand side. So you can see here, this sentence here, basically, if we want to get x by itself, we have to multiply B, this answer matrix, by the inverse of A. Now, the order does matter, okay? Because as you can see, this is a 2 by 1 matrix, and this is a 2 by 2 matrix. Your inverse will always go first, okay? So you must remember it has to be the inverse matrix multiplied by B for that answer matrix, okay? Very, very important. All right, so here's how to do it on your calculator. So we've got our 2 equations. You can see them represented here in matrix form. Okay, so we've got the coefficients of x in our first column, the coefficient of y in our second column. We've got our variables x, y, and our constants 21 and 29. Now you can in your calculator allocate A and C. I think that's a bit of a waste of time unless you're doing a lot of work with that matrix, because what's the point of storing something if you're only using it once? I don't know. I don't see the point in storing. But sometimes in matrices, you're doing a lot of work with a matrix, so you would need to use it more than once. And sometimes that's easier just to store it. But, copying and pasting is still pretty good. All right. Now, this is just what I said earlier. This is the calculation. So remember, to get rid of A, you multiply it by its inverse. And there you can see I is representing the identity matrix. And remember, your identity matrix is the same as 1. So effectively, we've got rid of the A on the left-hand side. But as with all equations, whatever we do to one side, we must do to the other. And we've got A to the power of -1 here. Oh, this is annoying. They use the values of A, B, and C in a different order. Doesn't matter. Okay. So I'm going to do this on the calculator to show you, because I'm not a big fan of these instructions. So I'm just going to try to remember the numbers. So 5, 2, 21, 7, 3, 29. Let's see how I go. Oops, let's use this one first. I think I've already forgotten. 5, 2, 7, 3. 5, 2, 7, 3. So there's our coefficients. Okay, so we had 5x plus 2y, and in our first equation, then 7x plus 3y in our second equation. Now, to get the values of x and y, we take, oops, that's what you get for having such small writing. Oh, what have I done? Sorry. Okay, let's start again. To the power of -1. Okay, so there's our inverse matrix. We don't have to press enter, but we're going to have to multiply that by our constant. So I'm just going to multiply it here, and 21, 9. So you can see that, 21, 9. So effectively, I've moved this matrix here, the 5, 2, 7, 3, over to the right-hand side by taking the inverse. Okay, so we multiply by 2, 1. Oh, sorry. 21, 29. And there's our solution. So that means x equals 5 and y equals -2. Now remember, I was saying you can use solve. Okay, I know we're not in linear equations, but it's the same thing. So 5x plus 2y equals 21. That was our first equation. Our second equation was 7x plus 3y equals 29, and we're solving for x, and there's your answer. Okay, so you can do it the matrix way, and you need to know how to do it using matrices, but I just wanted to show you that you can also do it using linear equations or using solve on your calculator. All right, let's scroll along. Okay, so here I've got 2 examples. Let me just get the calculator, try to remember these numbers. 4, 3, 7, 6. Yeah, no, I'm not going to remember that. Okay, so our first matrix, 4, 3, 6, -3. 6, -3. So 4 comes from the coefficient of x, 3 comes from the coefficient of y for your first equation, 6 from your coefficient of x for the second equation, -3 coefficient of y. So to the power of -1, now multiply that by your constant, so 7 and -27. And enter. So we've got -2 and 5, and that's your answer. So x equals -2, y equals 5. And we'll just do the last one, 3, 5, negative 2. There's no number there, but it's the number 1. So 3, 5, negative 2, 1. 3, 5, negative 2, 1 to the power of negative 1 times, and then just by your constants, 8 and negative 1. And just press enter. So we get 1, 1. I'm just going to do a quick check of questions in your textbook. Oh my gosh, there's hardly any questions in your textbook. There aren't any difficult ones in your textbook, but girls, do know that this seems easy, but in further maths, you do work with more than 2 equations, and you always have to be cautious of the order of your x, your y, and yours if you're working with z as well. So you're working with 3 equations. And putting in zeros. So for now, for general, you're not going to be exposed to those types of things, but I'm just forewarning you when you do it in a year's time that those questions will come up. Anyway, I've gone over time. I wanted to stick to 10 minutes. All the best, girls. Let me know if you need any help. Bye.